Okay, so before we start solving equations, I want us to practice simplifying. So if I have 32 raised to the 1/5 power. In these scenarios, this is really saying, we could change this to a radical, right? Do we all agree this is the same as saying the 5th root of 32? Does everybody know these two are the same thing? 32 to the 1/5 is the same as the 5th root of 32. And what is that asking us? It's essentially asking us what number times itself 5 times will give us the number under the radical. That's what it's asking. So what I want to do is I want to simplify this in a different way. I want us to change the base, and I'm going to write this out. Change the base. This is too big. The base to some number raised to the denominator of the exponent. Okay, what do I mean? It means I want to take 32 and I want to make 32 some number raised to the denominator of the exponent. Well, what's the denominator of our exponent? 5. So I need to change 32 into some number raised to the 5th power, and then now that's still raised to the 1/5 power. So what times itself 5 times will give me 32? 2. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times a 5th 2 is 32. So 2 to the 5th power is 32. So I didn't change the value of the problem at all. I just rewrote it in a different way. 32 is the same as 2 raised to the 5th power. But this makes our lives a lot easier because when you now raise an exponent to another exponent, a power to a power, what do you do with the exponents? What's the rule? An operation. What operation when you have a power raised to a power? Multiplication. Good. When you have a power raised to a power, it's multiplication. So when we multiply this, I have 5 times 1/5, but the 5s cancel. So what are we just left with? 2. So 32 to the 1/5 power is 2. All right, let's keep simplifying. 16 raised to the 3/2 power. So I want to change this into some number raised to what power? You want it raised to the power of the denominator of the exponent. So I need to change 16 into some number raised to the 2nd power, and then that will be raised to the 3/2. Exactly. 16 is the same as 4 raised to the 2nd power. And then what happens? We can cross simplify these. Power to a power we multiply, so the 2's cancel. So now we are left with 4 raised to the 3rd power, which is 4 times 4 times 4. Well, 4 times 4 is 16, times another 4 is 64. Okay, let's do another one. Nine raised to the negative 3/2 power. I'll deal with the negative after. Right, we'll deal with the negative at the end. Let's just try to change our base. So I want to change 9 into some number raised to what power? To the second power. And then that will be raised to the negative 3/2. So 9 could be what number raised to the second power? 3. Power to a power, we cancel. So now I'm left with 3 to the negative 3rd power. How do we fix a negative exponent? Where do I have to move it to? Does anybody remember? The denominator, exactly. To fix a negative exponent, we need to move it to the denominator. What if it's already in the denominator? Where do we move it to? To the numerator, exactly. So now I have 1 over 3 to the 3rd power. Well, 3 to the 3rd power is 3 times 3 times 3, which is 27. So we are 1 over 27. Okay, I'm going to have you try this one on your own. Oh, actually, I think I need to do this one with you. All right, so here we have 1/8 raised to the 2/3 power. If you have a fraction with 1 in the numerator, what I want you to do is change to a negative exponent. So this is going, if I'm going to change this to a negative exponent, won't this be 8 to the negative 1st power raised to the 2/3 power? And now what do you think I'm going to do with that 8? Change it into what? 2 to the 3rd power, exactly. We're going to change this 8 into 2 to the negative 3rd power, right? Because it's really a negative there. Raised to the 2/3. What happens with the 3's? They cancel. So we are left with 2 raised to the negative 2nd power. What is that?
4.
4 over where? 4 where?
Oh, you have to do the whole, like, that's 1 over 4.
1 over 4, you got it. Okay, so since we've just practiced simplifying, now let's go into solving. There's 2 different scenarios when we're solving. What color do I want to use? I wish we had a better pink color.
You can, like, customize it. Figure
More
out
colors. But I don't really like any of these pink colors.
You have to make your own.
Custom.
There's a custom?
Yeah, you gotta make your own thing.
What do I do?
You
Whatever you want is out of one.
you like go click on like the
You want a little scale or little.
Oh. Whoa. I don't like any of these. That's not bad. Oh, I like this one. It's like a purplish pink. I like it though. Okay. So we're going to, I never knew that.
Mine.
Solve exponential equations. All right, so there's 2 different scenarios when we're solving exponential equations. We have our first scenario, where the variable is in the exponent. And when the variable's in the exponent, we want to write both expressions with the same base, and in parentheses, I'm going to write smaller is better. Smaller base is better. And then also any fraction, write as an integer with a negative exponent. Okay, are we ready? Nail down. Okay, let's do some examples. So my first example is going to be 2 to the x is equal to 8. I know we could solve this in our heads. It's saying 2 to what power will give us 8. But we're not going to always be able to solve all of them in our head. So I want to practice with the easier problems, the right process. So when we get to the more difficult problems, the process is sort of intuitive. So according to my steps, I want you to change both of them into the same base. And I said going smaller is better. What does that mean? I want to change the 8 into a base of 2. And we can do that. 8 is the same as 2 raised to what power? The third. So now, when we have the same base, they're saying 2 to some number is equal to 2 to the third. Well, doesn't that number have to be 3 since these are the same base? So, yeah, you did in Algebra 2. X is equal to 3. Should have done it in Algebra 2. All right, let's say we have 4 to the x is equal to 8. We need to change them both into the same base. Can I make 8 into a base of 4? No. 4 raised to the second power is not 8. 4 raised to the second power is what? 16. So I can't make 8 into a base of 4, but I can make them both into what base? 2, and that's what we want to do. So 4 is going to become 2 to the second power raised to the x power. And 8 is 2 to the third power. Now that you have the same base, what you want to do is set their exponents equal to each other. So power to a power, you multiply, right? So this is 2 to the 2x is equal to 2 to the third. So now I say 2x is equal to 3, and we solve for x, so x is equal to 3/2. Let's do another one. So here I have 2 to the x is equal to 1/8. Well, what did I say to do with any fraction that has a numerator of 1? Change it into what? An integer with a negative exponent. So this becomes 8 to the negative first. We're going to change them both into a base of what? 2. So we end up with 2 to the negative third. What does this tell us? X is equal to negative 3. All right, number 4, 9 raised to the x plus 1 power equals 1 over 3. How about you guys try this one on your own? See what you come up with. It's a little trickier than what I've done, but I think you could do it. Are we ready? It is harder. It's not hard, it's harder. You want to see what I did? So how many people changed the 1/3 into 3 to the negative first? Raise your hand. Perfect. Now on the other side, I want to change 9 into a base of 3. So do we agree this is 3 to the second 9? But now that's still raised to what? X plus 1. When you have a power to a power, what do? Multiply. But because I'm multiplying this whole binomial, that 2 has to get distributed in. So this ends up becoming 3 raised to the 2x plus 2 equals 3 to the negative 1. Is that what stumped you all? If you got stumped? Yeah. Okay, so now that they have the same base, now we could set their exponents equal to each other. 2x plus 2 is equal to negative 1. Subtract that 2. We get 2x is equal to negative 3. Divide by 2. X is equal to negative 3/2. Okay, so now you guys try this one. When you wash that cup with the stickers, have you ever put them in the dishwasher? No.
I just don't wash it.
Okay. Dishwasher would ruin it, right?
Yeah, but even before I had the stickers, I didn't put it in the dishwasher.
You didn't put it in the dishwasher? we ready? Yeah. All right, what did we change them both into a base of? 3. So for 27, it's 3 to what power? The third, but now we're still raising that to the 2x power. And 9, we've changed that to 3 to the second raised to the x minus 2 power. Power to a power, we multiply. So we're going to have 3 raised to the 3 times 2x is 6x. And then here, remember, same thing as the problem we just did. When you multiply, you have to distribute into that binomial. So we end up with 3 raised to the 2x minus 4. Now that we have the same base, we set their exponents equal to each other. 6x is equal to 2x minus 4. I'm going to subtract that 2x on both sides. We have 4x is equal to negative 4, so x is equal to negative 1. Okay, one more like this type of problem, and then we'll show you this second scenario that we can see. Actually, 2 more problems in this one. This one's a little bit thought-provoking. So right now, there's no numerator of 1. So it's not like I could just change it into an integer by itself. We actually have to work with fractions. But I do realize in the first one, the numerator is smaller, denominator is bigger, but in the second one, numerator is bigger, denominator is smaller. So the bigger number's on top here. So I am going to do the negative 1. I am going to do the negative 1 to make them in the same format. Keep that in mind. Now I'm going to ask myself, well, what can I do? Can I change 4 over 9 into 2/3 raised to the second power? Right? 2 to the second power is 4. 3 to the second power is 9. Do we agree? Okay. So that's raised to the x minus 2. On the other side, I'm going to flip it. So I know I'm going to have the negative there. But now I'm going to have 8 to what power and 27, 8 to what power? What power, 2 to what power will give me 8? Good. And will it also work for 3 to the third power? Will that give us 27? Yeah, so this ends up becoming 2/3 raised to the negative third power because I flipped them. That's where I got the negative from. So now we have a power to a power. I'm going to distribute in. So we're going to have 2/3 raised to the 2x minus 4 is equal to 2/3 raised to the negative third. Now that our bases are the same, we set our exponents equal. 2x minus 4 is equal to negative 3. 2x is equal to 1. X is equal to 1/2. This was a tricky one. Okay, last one for this type of problem. Okay, how do I write the cubed root of 81 as an exponent?
81 to 1/3.
Excellent, 81 to the 1/3. What do you think I'm going to do with that 1/9?
Switch it.
Good, I'm going to make it 9 raised to the what? Negative first. Now we need to change them both into the same base. What base am I going to change them into? 9. So this stays 9, I should say. I'm going to distribute in that negative, so it's negative x minus 2. And on the other side, I'm going to have 9 to the second raised to the 1/3. So we're going to have 9 raised to the negative x minus 2 equals 9 raised to the 2/3. Now we're going to set those exponents equal to each other. So I have negative x minus 2 is equal to 2/3. Do you want to deal with fractions or do you want to eliminate the denominator? Deal with fractions or eliminate? It's not that bad. We could deal with the fraction. So we're going to add 2 to both sides. So now you end up with negative x is equal to 2/3 plus 2. But in order to add these, what do I have to create? A common denominator. So negative x is equal to 2/3 plus 6/3. So negative x is equal to 8/3. But then we have to get rid of that negative. So what do I get? If negative x is equal to 8/3, then positive x is equal to negative 8/3. All right, that's the last of that type of problem. The next ones, not too many of them, as our case 2, our second scenario. Is going to be when the variable is the base. So the first scenario was when our variable's in the exponent. Now in our second scenario, our variable as the base. So an example would be x raised to the 3/2 equals 64. That's like what this scenario was, something like this would look like. So what do we have to do? We have to say we are now solving, or we are solving for x. Or for the variable. We need to get the exponent to be 1. Say raise the exponential expression to its reciprocal on both sides. All right, this is going to be a super important thing. This next one, star, star. If denominator of the exponent we come up with is even, we must have plus or minus in our answer. And I'll show you what I mean. Okay, I'll show you what I mean here. Let's say I have x squared equals 15. If we were just solving this like we normally would, to undo a square, don't we take the square root? But the minute we take a square root, what do we have to account for? Plus or minus, not 2, plus or minus the root of 15, right? Well, let's talk about this in exponential. If I have x to the second equals 15, and I'm solving this exponentially, I tell you, raise the exponent to its reciprocal. So do we agree 2 is the same as 2 over 1? What's the reciprocal of 2 over 1? 1 over 2. So remember, taking a half is the same as taking the square root. That's why we have to account for the plus or minus. Anytime what we're raising it to has an even denominator, we always have to write plus or minus in the front. And we know a half is the square root of 15. But it's going to work out with nicer numbers, and I'll show you. Okay, one more step. Last one. We're going to say try to change the base of the integer to some number raised to the denominator of the exponent. If possible. And an example of this would be, I'll let you finish writing. Okay, so if we're solving this, we need to get x, the exponent on x to be 1. We need to get x all by itself. So my directions to you were to raise it to the reciprocal. What is the reciprocal of 3 over 2? 2 over 3. The denominator that we write, is that even? No. So do I need to do plus or minus? No. We only need to do plus or minus if the exponent we write has an even denominator. Since the denominator is not even, we do not write plus or minus. So now on the other side, I have to also raise it to the 2/3 power. Now I said, if possible, change this integer into some base raised to the 3rd power. What number raised to the 3rd power is 64? Not 2.
4.
4. So here, when we have x to the 3/2 raised to the 2/3, do we agree that cancels out to 1? So this is just x. And now I'm going to change this to 4 to the 3rd power raised to the 2/3. Why did I do that? Now the 3's cancel. So I'm just left with x equals 4 to the 2nd, which is 16. All right, 3 of these problems and then we're done. Sorry, 2 more of these problems and then we're done. Yes, you may. All right, to start, I need the exponent to be 1. So what am I going to raise both sides to? So it's raised to the 2/3. I need the reciprocal, which is? Good, 3 over 2. What do I really hope you recognize right now? The denominator of the exponent I wrote is what? Even. Therefore, what do I have to account for the other side? Plus or minus. Because the exponent I wrote has an even denominator, I always have to put a plus or minus. So now on the left side, the 2/3 and the 3/2 cancel. So now I'm left with 2x plus 1 is equal to plus or minus. What do you think I'm going to change that 4 into? 2 to the 2nd raised to the 3/2. The reason we're doing that is so the 2's cancel. So now I'm left with 2x plus 1 is equal to plus or minus 2 to the 3rd power. But what is 2 to the 3rd power? 8. So now we have 2x plus 1 is equal to plus or minus 8. I'll let you catch up before I show you what we're going to do next. We're going to have 2 answers. Yep, exactly. So now we need to split this up. We're going to have 2x plus 1 equals positive 8. And what else are we going to have? 2x plus 1 equals negative 8. And then we solve both of them. So 2x equals 7, x equals 7/2. That's one answer. And here 2x equals negative 9, x equals negative 9/2. All right, you want to try one on your own? The last one. Try this on your own.
I got this right, guys. Get the homework.
You always have a choice.
That's not the right one.
right, we ready? All right, so what would I have done? I would have done 3x plus 5 raised to the 4/3. I would have raised that to the 3/4. My denominator is even. Because my denominator is even, what do I have to account for? Plus or minus on the other side. So now I'm going to have 16 raised also to the 3/4 power. I'm now going to change that 16 into a base of some number raised to the 4th power. What is that number? 2. 2 raised to the 4th power is 16. And now we're raising that to the 3/4. Over here, these exponents cancel, so we're 3x plus 5. Here, the 4's cancel. So now we're 3x plus 5 equals plus or minus 2 to the 3rd. Well, we know 2 to the 3rd is 8. Do we need two different equations? What's wrong? Oh, I made the 3 as a 2. Sorry. That's what happens when I write too fast. All right, we're now going to make two different equations. 3x plus 5 equals positive 8, and 3x plus 5 equals negative 8. 3x equals 3, so x equals 1. Here, 3x equals negative 13, so x is equal to negative 13/3. How many people got that? Good job. Okay, we're done.